Good day. You should find these notes in your package. Power Notes, Part 1, the PET formula. You need this one. These will be the bulk of the calculations you'll do in this section on energy. And then we're going to visit in our third section where we study using electricity. So it says something called the PET formula. So power is the rate at which energy is used or produced. So if you operate a hydroelectric dam and you talk about power, you're talking about how much energy you're using. If you plug in a light bulb and it operates at 40 watts, you're telling how fast that light bulb goes through energy, converts electrical to light energy. Let's look at our power calculations. Well, we have a formula and it's related to energy and time. Energy we know is the ability to do work, and we have work which is energy in joules, force in newtons, distance in meters, and it turns out 1 joule equals 1 Newton meter. That's the way they talk in physics. It sounds very strange, but if you go on in physics, you'll quickly get used to it. Well, power is measured in watts, and power is energy divided by time. So P for power, E for energy, and a little t for time. You might have seen a 40-watt light bulb. That's using 40 joules of energy every second. If it's a 60-watt light bulb, that's going to be 60 joules of energy every second. Now you might be saying, well, what's a joule? Well, if you pick up something that requires a force of 1 Newton, maybe like an apple, and you lift it 1 meter, you have put in 1 joule of energy into that apple. So here is our formula, triangle formula. And the questions will simply be like this. They're going to ask you for power, or energy, or time. And then if they're asking for any one of these, it means that 2 other variables have to be given. Now, in senior physics, you don't have to memorize formulas. They are given to you. So, in Science 10, we're not going to ask you to memorize formulas. In the old days we did, that's why we had the triangle. So we will give you questions. If you're looking for energy, it's equals P times T. If you're looking for power, it's energy divided by time. And if you're looking for time, it's energy divided by power. Now, we've talked about power in watts, energy in joules, and time in seconds. And after so many years of math, you should be able to do some simple conversions. If you're given the time in minutes, you multiply by 60, and now you'll have the time in seconds. If you're given the time in hours, you multiply by 3,600, and now you'll have the time in seconds. There's 3,600 seconds every hour, 60 times 60. So you are expected, when you do these questions, to read them carefully and choose the right formula. That gets you 1 mark. Plug the numbers into the formula and show me that, 2nd mark. And put your answer with the correct units, 3rd mark. So here we see 400 watts, and we say, hey, that's power. We're asked how much energy, and there's our time. Well, we're asked how much energy, so we're going to write equals P times T. But you probably already spotted the curveball. We know our time has to be in seconds, and it's in minutes. Well, if it was 1 minute, that'd be 60 seconds. 10 minutes is 10 times as long, so it's 600 seconds. So here's how you attack it. First of all, you convert your minutes into seconds like that. Then you have your formula. Then you have your numbers that you plug in. You probably didn't need a calculator for that. And you get 240,000. And it's not the prettiest J, but that's a capital J for joules. That's how you're expected to show your work if you want the full 3 marks. So we have someone named Mac. It says Mac used a coffee maker for half an hour, calculate its power rating. Well, if we're after power, we need energy and time. So there's our energy. And then we have to know how many seconds in half an hour. And that's going to be 1,800 seconds. So half an hour is 0.5 hours. Multiplied by 3,600 seconds per hour, we get 1,800. So now we're ready to pop in our formula. P equals E divided by T. We're ready to plug in those big crazy numbers. And this is why you'll want to bring a calculator to class. And you get 1,100 watts. So that is a long time to use a coffee maker. And it may make you want to drink some iced tea. All right, let's see if we have more fun. We look at BC Hydro. So when you get your monthly bill, something to look forward to, you pay for electricity in the form of not power, but energy. So we're going to have to deal with that. We're going to have to look at our total energy used in that 1 or 2 month span, depending how long we go. So the lower the energy, the lower the cost to you. Good idea to turn off lights and things. But we also saw we got in some pretty big numbers here. Look at that. Almost 2 million joules. So to keep the numbers smaller, we're going to use things called kilowatt hours. The formula stays the same. Our units are just slightly different. So we say, well, how big is a kilowatt hour? What does that mean? Well, kilo means 1,000. If you run a kilometer, you've run 1,000 meters. And from earlier, we know 1 hour is 3,600 seconds. So we multiply those and we get 3.6 million joules equals 1 kilowatt hour. That's going to be handy. We have more conversions for you. So if we want to go from kilowatt hours to joules, we multiply by 3.6 million. And if we want to go from joules to kilowatt hours, we divide by 3.6 million. Very elegant, the beauty of math. For BC Hydro kind of questions, where we want it in kilowatt hours, our power must be in kilowatts. So if we have watts, we divide by 1,000. And we need our time in hours. And so this tells you how to go from seconds to hours, and also hours into seconds, and also you should know how to go from minutes to hours. In that case, you would divide by 60. Let's see what trouble we're in here. Same formula as before. So we just read the question and see what trouble we're in. Where are you? Okay, next page. So it says we have a 40-watt light bulb. We leave it on for 24 hours. How much energy does it consume? And we want in kilowatt hours. Then we want it in joules. And then eventually we want a cost. Well, 40 watts, we know we divide by 1,000, we get 0.04 kilowatts. Now the lovely thing is that 24 hours is 24 hours. So if we take 0.04 kilowatts and multiply by 24 hours, we get 0.96 kilowatt hours. And if we want that energy in joules, well, we take our 40 watts, that's no problem. But then we have to take our 24 hours and multiply by 3,600 seconds for every hour. You let your calculator do the work, and you arrive at 3.456 million joules. Now, some of you are saying, you know what? There's a faster way to go from kilowatt hours to joules. And you're right. You would take this number and just multiply it by 3.6 million, and you will get this number, guaranteed. Now, last question says, what's it going to cost if it's 10 cents per kilowatt hour? Well, we know we have that number of kilowatt hours, and we're simply going to multiply by 10 cents, and we get 9.6 cents. A little tricky to come up with the 0.6 cents, so you might have to pay a whole dime for that. But that adds up. You leave that on for a whole year, you're paying a little bit more money. Turn your lights off when you're not using them. Here we have a question. How long does a 1,200 watt kettle have to be on to consume 100 kilowatt hours of energy? How long is saying time? So somewhere back here, time is energy divided by power. So let's look at it here. So here's our energy, and here's our power. The only thing is, since we have kilowatt hours, we might as well make our 1,200 watts into kilowatts, and that's what we've done. We've divided by 1,000 to get our 1.2 kilowatts. Now we put in our formula, T equals E divided by P. We put in 100 kilowatt hours. We divide by the 1.2 kilowatts. The kilowatts and the kilowatt hours and the kilowatts divide out, and our answer is left in hours. So it's 83.3 hours or 300,000 seconds if you're interested. But if you stopped at 83.3 hours, that would be fine. Now, many students find this difficult, and it's a very sad thing that after years of math, you are struggling with this. This should not be difficult. Final things, you're going to be using the PET triangle formula. You're going to choose to solve for power, energy, or time. Anytime you're dealing with watts, then the energy has to be in joules and time in seconds. Anytime you're dealing with power in kilowatts, the energy must be in kilowatt hours and the time in hours. We will be doing some more sample problems, and by the end of it, you better have thorough notes and be able to follow these instructions.